my dear students, welcome to another session of virtual class. I'm Muhammad Alimuzaman, your subject teacher, Department of Physics, Milestone School and College. So, let's start. Okay, my dear students, now we are going to solve the short questions. It is from chapter 8, Reflection of Light. So, here is some sort of short questions. First of all, what kind of wave light is? We all know the answer. The answer is number 1 answer is electromagnetic wave. So it is electromagnetic wave. Then how many kinds of reflection there are? Dear students, we have two kinds of reflection. So the answer is 1 regular and second one is irregular. So, my dear students, again, we have two kinds of reflection, which is regular reflection and irregular reflection. Okay, so next one is, what is the angle between plane and normal? Students, when there is a surface or plane, we have to figure out the normal as 90 degree. So the angle between plane and normal is 90 degree. So hope you are all clear about the answer. Now question number 4, which law is supported by the figure? Okay, so here is the angle of incident is 30 degree and angle of reflection is also 30 degree. So my dear students, the result will be, it is the first law of reflection of light. So we can denote as, it is the first law of reflection of light. So for next, we need a blank space. So now we are erasing the answers. Hope you all have the copy. So okay, my dear students, now the next one, which is, there are how many kind of spherical mirror? My dear students, we all know that we have two kinds of spherical mirror. First one is concave and second one is convex. So these are the answer for question number 5, which is, we have two kinds of spherical mirror. First one is concave and second one is convex. My dear students, when the light ray incident at the curve point, then the mirror is known as concave, and when the spherical upper side light ray incident, then the mirror is known as convex. Here is two figure as concave and convex for further discussion. Now question number 6, which is, what is the angle between reflector and normal? It is the same question as 3. What is the angle between plane and normal? Reflector work as a plane, so no doubt the answer will be same. which is the angle between reflector and normal is also 90 degree. Now my dear students, what the type of image creates in the plane mirror? My dear students, for a plane mirror, when light ray incident at a reflector is on the upper surface, suppose from object O, the light ray incident perpendicularly at a plane mirror, then after reflection from the flow it just turn back at 90 degree. Then for different angle it will be maintain the reflection of light is first law, so the angle will be same. When we just extend the light rays behind the mirror, then we can position the image I as. Dear students, what we notice from the figure, it is the virtual image. So the answer is the type of image created in the plane mirror is virtual image. It is the answer. So you can write the answer. It creates virtual image at plane mirror. So my dear students, the answer is it creates virtual image at the plane mirror. So my dear students, now we are going to solve the number 8, which is reflection angle at the figure. What is the reflection angle at the figure? So my dear students, here is a figure which is we can draw it again. There is the angle given here is 50 degree. So we all know that from question 3 and 6, which is the angle between plane and normal, or the angle between reflector and normal is 90 degree. So here the total angle is 90 degree. If we subtract 50 degree from the 90 degree, then the answer will be 40 degree. Why 40 degree? It is the angle of incident. But the question is, what is the angle of reflection? We all know that from the law of reflection, the angle of incident and angle of reflection is equal. So the answer will be same as here, also 40 degree for both portion. So my dear students, the answer is 40 degree for question number 8. Now what type of image creates in the convex mirror? Dear students, we all know that we have two types of image, which is real and another type is virtual. So in the convex mirror, the light ray are not directly meet at a certain point, so the result will be the virtual image. We have to extend the rays and then the light ray meet in a certain point. So in that case, the image create, which is virtual image. We can draw the image as a figure like this. Is a simple convex mirror, and for that, if we figure out as C for center of curvature, F for the principal focus behind the mirror, then the image will be, if the image after reflection we have to extend in that way, and if the object A, B here. Then another we have to light ray, which is directly reflected as a wave, which is directly incident at center of curvature. So my dear students, we notice that this is a virtual image. So the answer is, it is virtual image. So my dear students, here is the answer of question 9. So it is the first section from the short question part. Now we are going to describe another section which is also about short questions. Okay my dear students, now the next portion, which is what kind of mirror used in a vehicle. So a vehicle means motor vehicles, as a car, truck, bus, etc. So here the answer will be convex. So my dear students, this is the answer of question number 10, which is what kind of mirror used in a vehicle. The answer is convex. So my dear students, now question number 11, which is what will be the distance of image when an object placed 2 meters before the plane mirror. We all know that from previous discussion, the object distance and the image distance is always equal for a plane mirror. So here the answer will be same, 2 meters. Now question number 12, what is the relation between F and R for a spherical mirror? We all know that, my dear students, F is denoted for the focal length and R is for radius of curvature. So the relation is F is equal to R by 2. Okay, so here is the answer for 12, where F is equal to R by 2, which is focal length is equal to half of radius of curvature. Now my dear students, where will we create the image of AB? Here the place of object is in between center of curvature and principal focus. So we have to draw the figure geometrically, where we can take two portions C and F here, and then object AB. All know that when a light ray incident along parallel to the principal axis, after reflection it passes through principal focus. Then we have to draw another light ray, which is from center of curvature. Then we can notice that after reflection the image will create in between infinity and center of curvature. So the answer will be 13, between infinity and center of curvature C. So my dear students, here we have to maintain the formula, which is F is equal to R by 2. F is equal to for focal length and R is equal to for radius of curvature. So there is the figure we have to draw, and for short question we have to remind the answer, which is the image will be in between infinity and center of curvature, while the object placed in between center of curvature and principal focus. Now my dear students, we need to erase that section. Question number 14, what will be the image size when an object placed at C? My dear student, is also a figure we have to draw and put the figure with geometric equation, which is f is equal to r by 2. First we draw object, then we have to take the another way, and after a while we notice that the image create at the same place where the object remains. So for 14 the answer will be same, which is C for center of curvature. Now my dear students, question number 15. What will be the image size when the magnification is 5 and object size is 1 meter? My dear students, we all know the formula M is equal to L prime by L, where L prime is the image size and L is the object size. Then we have to put the value 5 for magnification, object size 1, then image size L prime, then the answer will be L prime is equal to 5 meter. So my dear students, for question number 15, the answer will be 5 meter. So my dear students, now it's time for question number 16. What kind of mirror used to observe face? The answer is very clear. It is plane mirror. So my dear students, this is the end of this section. Now we are going to solve the next section, which is question number 17 to question number 20. So my dear students, this is the last portion of the short question section. And number 17, what will be the focal length when the radius is 14 for a concave mirror? We know that the formula is f is equal to r by 2. Here the radius r is equal to 14, so the answer is 7. So my dear students, for 17 the answer will be 7. Okay, now question number 18. What will be the size of image if magnification is less than 1? My dear students, if the magnification is less than 1, then the result will be large. So my dear student, we can write large for this section. The answer will be large. Now question number 19, my dear students, in which mirror it creates the real and virtual image? We know, my dear students, we have the two kind of mirror, which is plane mirror and spherical mirror. In spherical mirror, we also have two kinds of mirror, which is concave and convex mirror. In that case, the concave mirror is a kind of mirror where the both virtual and real image creates. So the answer will be concave for question number 19. So my dear students, you have to write the concave mirror. Question number 20. What is the magnification of plane mirror? My dear students, we know that for magnification we have two formulas, which is L prime by L or M is equal to minus V by Q. In both sections, we know that the object size and image size same, or the object distance and image distance is same for plane mirror. So my dear students, for this section the answer will be same, because if the object size is 1 meter, the image size will be also 1 meter, so resultant the magnification will be 1. So my dear students, what is the magnification of plane mirror? The answer is 1 for plane mirror. Okay, so you can write 1 for plane mirror, so the answer will be 1. So this is the end of this session, my dear students. Hope we will meet in different session again with a new lesson. Till then, bye bye.